Okay, let's dive into this explainer and crack the code on how to really truly master your Cambridge computer science questions. We're starting off today with a deep dive into the binary and denary systems. Welcome to the explainer. Today we are taking a fascinating, no-nonsense look at the actual mechanics behind exam success. Think of this like training for a high-stakes athletic event, like an Olympic decathlon. You can't just know how to run, you have to know the strategy for the hurdles, the long jump, the whole shebang. Whether you are studying under syllabus codes 0417, 0478, 2210, or even 9618, the strategy remains exactly the same. We are moving way beyond just memorizing data representation facts. We are looking at exactly how to apply that knowledge to score the absolute top marks. Because, it's not just about what you know, it is entirely about how you frame it for the examiner.
So here's a massive question for you. Have you ever felt that incredible frustration? You spend hours memorizing all the facts, you completely understand the math behind binary and denary conversions, you do the past papers, but you still drop points on the actual exam? It's literally the worst feeling. Today, we are going to explore exactly why that happens, and more importantly, how to fix it once and for all. Because in the realm of computer science, there is a massive, massive difference between simply recognizing a term, deeply understanding it, and actually applying it to a complex, scenario-based examination question. Far too many intelligent, hardworking students stop at mere recognition. They see a term, they think, oh, I know what that is, and they write down a textbook definition. And unfortunately, that right there is exactly where the marks slip away. The examiner wants to see your analytical muscles at work. We have a really brilliant, action-packed structure lined up for you today to tackle this exact problem. First, we'll expose the generic answer trap. Second, we'll explore binary in real context. Third, we'll introduce a bulletproof 4-step exam method. Fourth, we'll show you how to avoid classic mistakes. And finally, we will wrap up with the ultimate revision system. Let's jump right into Section 1, the generic answer trap. We need to focus on moving beyond isolated labels. This is the pitfall where perfectly good knowledge just gets completely lost in bad delivery.
Now, what's really interesting and absolutely crucial to understand about this slide is the stark contrast between the two approaches. Imagine looking at two students' answers side by side. On the left, we have a student who is simply memorizing abstract theory. They are writing down short, generic labels completely out of context. On the right, we have a student who is actually applying that knowledge using precise terminology and connecting it directly to the specific digital scenario provided in the question. In Cambridge IGCSE and O-level computer science, you simply do not reach those coveted highest marks by writing short, isolated labels. It just doesn't work. The examiners are specifically looking for precise terminology. They desperately want to see that you can explain a process clearly, and, this is the golden rule, connect your explanation directly back to the unique digital scenario provided in the prompt. A generic answer, no matter how factually accurate it might be in a vacuum, simply won't cut it. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving smoothly on to Section 2, binary in real contexts. We really need to shift our mindset to solving digital problems, because binary isn't just a theoretical math puzzle that exists only on a whiteboard. It is the literal language of our modern digital infrastructure. Instead of seeing binary and denary systems as just a frustrating math exercise, we have to wake up and recognize them as the fundamental, ground-level solutions driving all of these incredible real-world applications. Think about it. The exact same binary patterns and logic systems appear in the smartphone you use every single day to process high-definition pixels. They are the backbone of the secure communications protecting massive global banking and retail systems. They are the core of the industrial control systems managing cutting-edge robotics. When you look at media processing or secure communication, it all boils down to ones and zeros solving complex problems. By recognizing these real-world contexts, you start to understand not just the name of the concept, but the absolutely crucial reason it is being used in the first place. You move from memorizing to truly understanding. This brings us to a really powerful realization. When you genuinely understand the digital problem that binary solves, the terminology becomes meaningful rather than memorized in isolation. It transforms from a dense, boring list of facts into a logical, dynamic toolkit that you intuitively understand how to use. Think of the questions you should be asking yourself. What hardware is actually involved here? What specific process is taking place behind the scenes? If you answer those contextual questions first, the terminology suddenly clicks into place. It's like a giant puzzle coming together. You aren't just reciting words, you're explaining a living, breathing system. So how do we guarantee those top marks?
Let's move to Section 3, the four-step exam method. We are going to take you from a theoretical model to a highly practical method. This is where we build a framework you can rely on under pressure. Listen closely, because this four-step path is your ultimate technical methodology for tackling literally any scenario-based question. It ensures you never, ever write a generic response again. Step 1. Pause, take a breath, and identify the exact requirement of the task. Look at the command words. Are they asking you to describe, explain, or evaluate? Is the question testing process explanation, hardware selection, or logical reasoning? Step 2. Classify the components involved. What specific data, hardware, or process are we dealing with? Step 3 is vital. Explain how the process works in a clear, logical sequence. Imagine you are explaining it to another learner who needs to follow it step by step. Don't skip steps assuming the examiner knows what you mean. And finally, step 4. Always check if the question is asking for causes, effects, advantages, or design decisions, and link your explanation directly back to that specific context. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
So the crucial takeaway here, the absolute non-negotiable rule, is that if the exam question mentions a local school, a busy office network, a specific e-commerce website, or an embedded system inside a factory robot, your answer must live entirely inside that specific context. You have to anchor your explanation to their scenario. I can't tell you how often students know the core theory perfectly, but they bleed marks all over the page because they write everything they know generally without any direction, rather than tailoring their knowledge to the specific details provided in the prompt. Anchor your answers.
Now for Section 4, avoiding classic mistakes. Even with a brilliant framework in place, we still need to carefully navigate the common roadblocks and examiner pitfalls that trip up thousands of students every year. Examiners frequently, and I mean constantly, see students mix up these closely related concepts. So training your brain to compare them directly is an absolute game changer. The theoretical foundations of computer science often depend on distinguishing between concepts that sound very similar but function in entirely different ways. Let's look at a few. If you confuse memory, which is volatile and used for current processing like RAM, with storage, which is non-volatile for long-term data keeping, your whole explanation completely derails. Same goes for a protocol, which is the set of rules, versus a service, which is the application itself, or a compiler, which translates all the code at once, versus an interpreter, which goes line by line. And don't even get me started on validation versus verification. Validation checks if data is sensible, verification checks if it matches the original source. You absolutely must train your brain not just for single-topic explanation, but for direct, rigorous comparison.
Make sure you watch out for these classic wrong turns. It is so heartbreakingly common to see a student state a totally valid advantage of a piece of technology, but completely forget to provide the reason why it's an advantage in that specific context. Or they might name the perfect device for a network solution, say a router, but offer absolute zero explanation of how the device actually operates to route those data packets. Using vague wording or skipping critical steps in a logical sequence because you're rushing are the fastest ways to miss out on full credit. Always explain the how and the why, not just a what. Don't describe a related technology just because you know it better. Answer the question in front of you.
Finally, we have arrived at Section 5, the ultimate revision system. Let's look at exactly how to cement this knowledge, how to start layering your learning so it's instantly ready and accessible on exam day.
I call this the 3-pass revision cycle. It's a layered, strategic style of studying that perfectly matches exactly how Cambridge exams combine raw theory with applied reasoning. You don't just read a textbook once and hope for the best. In your first pass, you lock down those key definitions and clear up the contrasts we just talked about, like memory versus storage. In the second pass, you step it up. You aren't just reading. You are actively rehearsing worked explanations aloud and sketching out system diagrams from memory. But the real magic, the thing that pushes you to an A star, happens in the third pass. This is where you focus intensely on exam adaptability. You test yourself by changing the scenario, mixing terms, forcing yourself to justify why one method or device is better than another in a brand new, unseen context. To truly know if you've mastered a topic, use this incredibly reliable memory structure. If you can confidently run your topic through these 4 memory prompts out loud, what is it? How does it work? Where is it used in the real world? And why is it better or worse than an alternative? Then you are officially 100% ready for the exam. This is your ultimate self-check. If you get stuck, even for a second, on any of these 4 questions, it simply means you need to go back, look at a worked example, and rebuild that topic in your mind until it's rock solid.
I'll leave you with this provocative thought. If your exam was tomorrow morning, could you grab your notes right now, look at the binary and denary applications, test yourself on those 4 prompts, and pass with flying colors? By shifting your mindset from rote memorization to applied, contextual reasoning, you take total, absolute control of your exam mastery. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.